Hello everyone, today we'll talk about the solution to the problem shortest subarray to be removed to make array sorted. The statement is short and sweet. Keep in mind that we are looking to remove a subarray, so a contiguous subsequence, and not just any subsequence. The same problem, but with removing a subsequence, has a solution that has noticeably shorter code. I wouldn't say it's easier, but it's a very classic problem, so you might want to think about it later. What if it doesn't have to be contiguous? But here it has to be contiguous. And a common trick when thinking about removing contiguous subsequences, removing subarrays, if there is exactly one subarray that you want to remove, is that here is the whole big array, here is the subarray that you remove. What are you left with? You're left with a prefix concatenated with a suffix. And this is a very common pattern that can make solving problems easier. Sometimes you get a problem where you're being told about taking some elements from the left and some from the right, and this is the same as removing a subarray in the middle, or as in this case, you want to remove a subarray from the middle, which is the same thing as selecting some prefix and some suffix that do not overlap. And it's important in this problem and useful in this problem because we want the final array to be non-decreasing, so increasing essentially. And what does that mean? That means that, of course, this beginning part has to be non-decreasing. This part has to be non-decreasing. Because if either of those parts are not sorted, they violate this non-decreasing version, then concatenating them will make things even worse. And it's important that this endpoint is lower than this starting point. That's exactly what we need. Lower or equal, of course, because we want non-decreasing. So that means that we can always take the longest increasing prefix and no suffix. And so it's important for us to find the longest increasing prefix. The same thing for the suffix, and when increasing I mean non-decreasing here. We can always take the longest non-decreasing suffix. Those are two options for a solution. Maybe they are the best solution. However, it's possible in the case where, let's say, the prefix increases, the suffix increases, and we are given here that it starts at some point within this increasing prefix, we can take some shorter prefix, which will allow us to take a longer suffix. Or maybe we can take a bit longer prefix and a bit shorter suffix, but it's even better. So we can combine the prefix and suffix to maybe achieve an even better result. And what can we do with that? Well, we can notice a standard pattern for two pointers, which is that if we have a prefix, and this is the longest suffix that's good for it, then if we take a longer prefix, that means that we are higher on this increasing prefix. So that means that we either can still start from the same position, or maybe we have to start from a higher position, so take a shorter suffix, which means that we can start by taking short prefix, whole suffix, and we add element by element to our prefix, removing elements from the left of our suffix for as long as they cannot be connected, so the leftmost element of the suffix is smaller than the rightmost element of the prefix. And this is the whole solution. The code doesn't look maybe very pretty, but there is nothing difficult happening here. We want to get the longest increasing prefix, longest increasing suffix in the variables left and right. So this is just very standard, nothing to see here. And we can, well, this is a print statement that I forgot to remove, but of course it doesn't really matter here. It makes code a bit slower. And you have to calculate first the result taking only the prefix or the suffix, because those are possible results. If at that point the result is equal to the length of the whole array, we can return 0, because that means that the whole array is sorted. You do not have to remove any subarrays. Otherwise you have to remove some subarray, so combine a prefix and a suffix. So you'll be taking I, the ith element will be the last element of the prefix that you take. So you have to make sure that the first element of the suffix that you take is not smaller than it. So j will be the first element of the suffix you take. Of course, j has to be less than n, because it has to point to an element within the array. For as long as that element is too small, you just increase j by 1. And after that, you have a correct combination of prefix and suffix. So for the prefix that takes the ith element as the last element, j is the leftmost element from the suffix that can be taken. So you take the maximum of the previous result, and you take I plus 1 elements from the left and n minus j elements from the right. In total, those are the elements that you want to keep. And of course, since we're calculating the number of elements that we want to keep, we get n minus res, because that's the size of this subarray.